Hi there, graders. It's Ms. Hanamio. Let's just take a few moments of our time this morning to look over our DMA for today. So we have week 24, day 2. Today's Tuesday, March 9th. So let's look at our first problem. It has to do with rounding, and we can also call that estimating. When we estimate, we are thinking about how much would 701 and 109 be. Not exactly, but about. Keyword being there, about. So it says for us to round to the closest 10, then add. So remember your multiples of 10 chart that you have in your notebooks. Here's your multiples of 10 chart. And when you go to look for the number 701, 701 is going to be between 700 and 710. Those are the two tens that 701 is between. So again, just as a reminder, if you think about on a number line, you have the two tens, which is 700 and 710. Remember, in between your tens is 5. Now, if I think about, okay, well, where's 701 going to be on here? Well, it's going to be probably right around here, right? Because this would be 701, 702, 703, 704, 705. So 701 rounded to the closest 10 would be 700. So 700 plus, now let's go back to our chart and look where 109 might be. So if I look at my tens chart, 109 would be right around here. Now we look at the two tens it's between 100 and 110. Now some of you might say, well, 100 is not a 10, Ms. Sunil. Well, it is a 10 because as soon as you get to the 10th 10, you have created 100. So when you count by tens, these hundreds do end up being multiples of 10 because when I count by tens, I don't skip 100. I say 100, 110, 120, 130. So 100 is a multiple of 10. So I'm going to go back to looking at a number line again. So 109 is between 100 and 110 when we're looking at tens. Now, in the middle is 105, right? And so where is 109 here? Now remember, as soon as you pass 5 in the middle of these tens, you round up. If it's less than 5, which means 4, you would round down. But this is going to be 109. So that tells me it's going to be closer to the 110 when rounding to the closest 10. Now, when I add these together, 700 plus 100 is 800. I don't have any tens here in my tens place, but I do have one 10 here, which is 10, and no ones because we're rounding to the closest 10, so there shouldn't be any ones. So I have 810 is my rounded estimate. Now, exactly how much would my sum be? Well, I could just take and add these together to get my sum. 9 plus 1 more is 10, so that means I have 10, and 700 plus 100 is 800. So it just so happens that my exact sum is also going to be my rounded sum. So that's a coincidence. That doesn't happen very often. So we can see that these are really close to each other, right? Let's take a look at our fraction problem. They're asking you to use a less than, greater than, or equal symbol to make this statement true. So we want to know is 1/6, because I have one shaded, out of the 6 parts, this is going to be shaded one of the 3 parts. So again, it doesn't tell us to look at the shaded parts, but we're assuming that we're going to look at the shaded parts, right? So 1/6 is, well, remember, when we look at parts of the whole, If you cut something into 3 equal parts, these are going to be larger parts in the whole, right? And if I look at a third, thirds are going to be larger than sixths. So we know that 1/6 is smaller than or less than 1/3. So 1/6 is less than 1/3. And remember, you're reading it from left to right, not backwards. So although 1/3 is larger, remember we're reading it from left to right. Okay, let's take a look at our square here. It says to divide the square into sixths, label each sixth with the appropriate fraction. So remember I told you you could start with half because 6 is a multiple of 2, right? Or half. So it goes 2, 4, 6. Now, when I take each one of those halves, I need to make it into 6 equal pieces. Now, how do I do that? Well, I need to make these into thirds. And I need to take this half and cut it into 3 equal pieces. So what I'm doing is I'm taking this half, cutting it into 3 equal pieces to make 6. So this would be 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. So together they make 6/6 altogether. Now that's one way you can make 6, but another way you could think about making 6 is starting with thirds. So that's what I like to usually do, is start with thirds first and then so if I start with thirds, and I'm going to just do that here. So a third, and a third. Now I'm going to take each one of those thirds and I'm going to cut them into 2 pieces. So each one of these is now 1, 2, 3, 4, 5, 6. So each one of these is 1/6. So I'm doubling my parts in my whole by cutting it into 2, each one of those thirds, into 2 equal pieces. So my denominator now is 6 because I cut each third into 2 more parts. And when I'm doing that, I'm making more parts, but they're smaller parts, right? Smaller pieces, okay? So it said to label each 6. So I've done that. I've divided into 6 equal pieces. Those are my 6. So I've done everything that I needed to do. Now, one of the things that we talked about yesterday in our problem was we talked about equivalent fractions. So think about, I just made thirds. How many, and this is going to be your discussion question for today, how many sixths are in 2 thirds? So how many sixths are in 2 thirds? So that's what I want you to think about. Before we broke this up into 6 equal pieces, we started with thirds. Remember? Started with thirds. If you don't remember, go back to the beginning. So those are where my thirds were. So think about that one and put it into the discussion. 2 thirds is equal to how many sixths? And the last problem says there is a group of 6 families. They attend a basketball game together. After the game, they went out to dinner. If there are 7 people in each family, so I'm just going to go to the back and answer how many people went to dinner. Now, these are some big families. If you have 7 people in each family, wow, that's a lot of people. But let's think about it. Okay, so families are groups, right? So 6 families, that means I have 6 groups, right? Family 1, 2, 3, 4, 5, and 6. Now, it said there are 7 people in each family. So I'm going to put a 7P, 7 for 7 people. Now, they want to know how many people went to dinner. So if you're looking for a total number, we're using what operation? Right, we're using multiplication because I have 6 groups. That's my first factor because those are my families. I have 7 people in each family. And I want to know how many people are going to dinner.
Now, if I know how to count sevens,
well, then I can add 7 plus 7 is 14, plus 7 is 21, plus 7 is 28, plus 7 is 35, plus 7 is going to be 42. Now, if I don't know how to skip count by sevens, or if I need to, I can use addition. 7 plus 7 is 14. 7 plus 7 is 14, and 7 plus 7 is 14. 10 plus 10 plus 10 is 30. 4 plus 4 is 8, plus 4 is 12. So I can group and add those together by adding 14s, and I get 42 people. Or if you know your multiplication facts really well, which some of you might, that would be great also. So you could also use 5 groups of 7, which would be 35, and then add another group of 7. So think about that. If I have 5 groups of 7, which most of us know that that's 35, then I add another group of 7 for another family and add, not 6, add 7 more. Then 35 plus 7 is going to be 42. So several different ways that you can look at this, guys. Whatever makes it easier for you. But remember, you have strategies to help you solve the problems. So don't guess. Use a strategy to help you get the answer correct. Okay? Now we can say there are 42 people going to dinner, right? Because that's what they wanted to know. How many people are going to dinner? Because 6 groups with 7 people each, keyword there being each, 7 people each, will be 42 total. All of them put together. Now, again, we've shown how we can solve this by drawing a model. We've written an equation. We've actually done several different equations that we could actually use to prove our thinking. But we could add 7 plus 7 plus 7 plus 7 plus 7 plus 7, 1, 2, 3, 4, 5, and 6 is going to be 42. So 6 times 7 equals 42. And that's it for today, guys. So don't forget to go back to your discussion. That discussion question is going to be on how many sixths does it take to make 2/3? Okay? If you need to use your fraction bars, you can always do that as well. But again, how many sixths does it take to make 2/3? So can't wait to see what you come up with in your discussion, and have a great day.